This video is to show you how to do the O series on IXL for Algebra 2. First of all, we have a notation here, which is a little circle between two function names. And this little circle means follows. So, for example, if I say f follows g, then that means we do the g operation first, and then we do the f operation on what comes out of the g. Okay, so basically we're going to say, we're going to take an input, which is, in this case, -1, and we're going to feed it to the g function, and then we're going to feed it to the f function. Okay, what does the f function look like? It looks like this: 2 times the input plus 3. What does the g function look like? It looks like this: 3 times the input. Okay, so we're going to take our -1, and then we're going to put it inside the g function first, because it's f follows g. So we're going to have 3 with -1 fed to it. Okay, that's g. And then we're going to feed that to the f function. So we're going to put that in the input of the f function. So we're going to have 2 times that plus 3. You can also think of it as, okay, f is on the outside, g is on the inside. So f is 2 with a big parentheses plus 3. What are we going to put inside of it? We're going to put g, which is 3 times the input. What is the input? -1. Okay, so let's simplify this. So -1 times 3 is -3 times 2 is -6 plus 3 is -3. Okay. Here is a slightly different case. This one has f follows g and the input is x. But that's not a number. Well, basically, if you leave it in this form, you're making a general equation which can be used to substitute any number in afterwards. So let's try that. So we're going to have f follows g with an input of x. So it'll be f, which is 2 parentheses plus 3. What goes inside the parentheses? The g function. It's going to be 3 times parentheses. What goes inside the g function? The x. Okay? So you could think of it as f is on the outside, g is on the inside. The other way you can think of it as, you're going to start with the input x, you're going to operate the g function first, so it'll be 3 times x. After that, you're going to take the output of that, and you're going to do the f operation on it, which is 2 parentheses plus 3. Okay, either way you get the same thing, right? So basically you can leave it in this form. You could simplify it a little bit. 2 times 3 is 6, so I could simplify this to be 6x plus 3, right? Okay. Now look at this. I'm going to do the inverse operation, so or the opposite direction here. So instead of f follows g, I'm going to do g follows f. So I could think of that as, okay, first I'm going to put f in the inside, and then I'm going to put g on the outside, right? So let's see, I'm going to put f on the inside, so f is 2 input plus 3. What's the input? It's x, right? The input is x. And that is the f function on the outside of the g function, which is 3 times the input. I'm going to simplify that. I'll get 3 times 2x plus 3, which is equal to 6x plus 9. Another way to think of it as is the g function is on the outside, so g is going to be 3 times something on the inside. What's on the inside? The f function is on the inside. I'm going to put 2 input plus 3. What's the input? It's x. Okay, and then you get the same thing again. All right. What if I have this here? I have basically the same thing, f follows g, but instead of x, I have a j. All you need to do is substitute the j in for the input. That's it. So the f function is on the outside, and the g function is on the inside. The f function, remember, is 2 input plus 3. So it's 2 input plus 3. The g function, which goes on the inside, is 3 input j. Okay, so instead of x, I put in j. Now here, I have f follows g with an input of -4. The only difference here is now I have a slightly more complicated function of f of x here, which is x squared. So here I'm going to say first, okay, f is on the outside, g is on the inside, so I'm going to put f on the outside. I'm going to put, oh, by the way, I'm going to rewrite this so that it doesn't have x's in it. I'm going to say input squared, and this one is going to be input plus 3. So the first I'm going to say f is on the outside, so I'm going to put something squared. G is on the inside, which is going to be something plus 3. That something is the input, which happens to be -4. Then I'm going to simplify this. -4 plus 3 is -1. -1 squared is +1. Okay? Moving on. I'm going to identify some inverse functions here. The inverse function of 3x, or multiplying something by 3, is x divided by 3, or dividing something by 3. The inverse function of multiplying by 3 is dividing by 3. What about the inverse function of subtracting 3 from something? That would be adding 3 to something. How can I check these? Okay, so first I'm going to say 3 times something is the inverse function of something divided by 3. So I'm going to take something and I'm going to make it go through both processes, and then it will end up coming back to being itself again. So first I'm going to take like the number 8, and I'm going to multiply it times 3, and I'm going to get 3 times 8, which is 24. And then I'm going to take that, I'm going to feed it into the division one, and I'm going to have 24 divided by 3, and I end up with 8. See, I got the same thing back again. So if I do both the function and the inverse function to the input, and I get the input back again, that means that it is indeed an inverse function. Of course, it has to work for every single number, all right? So the best way to do it actually is to put in x, because if x comes out to be the exact same number, then that proves that it works for any number, not just for one particular number like 8. Maybe it works for 8, but it doesn't work for -7, right? It has to work for every number. So that's why, for example, if we're going to check these two, I'm going to say, okay, first I'm going to put in x into the x minus 3 function. I get x minus 3. Then I input it into the x plus 3 function, and I get x minus 3 plus 3, which is x, and I get x back again. So that really proves that these are inverse functions because I got the same variable out that I put in, and the variable can be any number, so that means any number works. Okay. The inverse function of x plus 4 is x minus 4. The inverse function of x divided by 5 is 5 times x. Okay, so those are the basic 4 inverse functions. What happens if you have this function table? You have x values 1, 2, 3. You have f of x values of 2, 3, 10. Now we've done this many times. The function or the value of f of 2, or 2 input put into the function f, is going to be 3, right? What if I say, what is the inverse function of 2? What am I doing here? Actually, what I'm doing is I'm pretending that the y value is 2, and I'm wondering what the x value is. If I'm saying, what is the inverse function of 2, I'm saying 2 is the y. So if 2 is the y, the inverse function value is 1. Okay? So basically, that when you do a function, you're taking the first number, okay, and you're making it go back. You're gonna take the first number, and then you're gonna figure out what the second number is when you use the function. When you use the inverse function, you're going the opposite. You're taking the second number and you're trying to find the first number with it, okay? So if you're saying f inverse of 2, you're saying, oh, I'm starting with the 2 on the right side and I'm seeing what left side number corresponds to that, what x corresponds to the y I'm given, okay? You can do the same thing with a graph. If I say f inverse of 2, I'm going to take the y value of 2 and figure out what x value corresponds to that. In this case, it's a 1. Now I'm going to show you how to find an inverse function of a two-step function like this one, okay? We know that the inverse function of 4x is x divided by 4. We know the inverse function of x minus 2 is x plus 2. But what is the inverse function of something that looks kind of complicated like this? Well, there's two steps to doing this, okay? One is that when you do an inverse function, basically the input becomes the output and the output becomes the input, right? Because like if you have 2 and you make it go through the inverse function x minus 2 and you get 0, right? If you want to find the inverse function, you want to take the 0. What inverse function gets a 2 back? Well, it happens to be x plus 2, right? So do you see how the input becomes the output and the output becomes the input? Okay? So basically what that means is x becomes y and y becomes x. So the first step you do to find the inverse function is you take the x and the y and you exchange them. It's called variable interchange. And you're going to take the y and you're going to make it into x. And you're going to make the x into y. And you're going to get this function, okay? And then what you're going to do is, okay, whenever we make a function, we always want the y to be on the left by itself. So we're going to solve for y using algebra. So we're going to add 2 to both sides, and we're going to get x plus 2 equals 4y plus 0, because the negative 2 plus 2 added together and canceled out. And then we divide both sides by 4. We get y equals x plus 2 divided by 4. And this is supposed to be the inverse function of this. Can we make sure? Sure we can. So we're going to take like a value, for example 2, and we're going to put it in the function 4x minus 2. That'll give us 2 times 4, which is 8, minus 2, which is 6. And then we're going to put it into the inverse function, which is x plus 2 divided by 4. We're going to get 6 plus 2, which is 8, divided by 4, which is 2. And we just got the same thing back again, so it worked. Okay? So these are indeed inverse functions. So the first step to finding an inverse function is to switch x's and y's. And then the second step is to solve for y. Okay? Another thing you might notice about inverse functions is if you take an inverse function, like let's say your inverse function is 4x minus 2. Okay? If you graph 4x minus 2, it is a line, a diagonal line, which intersects at y equals negative 2 and has a slope of 4. Okay? It looks kind of like that. Okay? Now, if you find the inverse function is actually a reflection about the line y equals x. We just did reflections, right? If you take the blue line and you reflect it about the green line and get a pink line, which looks kind of like that, you have found the reflection or the inverse function of the blue line. And guess what? The pink line has the equation x plus 2 divided by 4, because we just found using variable interchange that the pink line has that equation, whereas the blue line has this equation. Okay? So, since we know that the y equals x diagonal line is the reflection, it's where the axis of reflection to find the inverse function, we can also figure out when a function has no inverse function. Okay? What I mean by that is, remember that a function cannot have two y values for any x value, right? And let's take this function here, which is a function we're familiar with. It's called a parabola. We've used it in the past, right? So does this function which we're very familiar with, we use it all the time, does it have an inverse function? Well, I'm going to draw the y equals x line, and it looks kind of like this. And then I'm going to take this and I'm going to reflect it about the green line, and I'm going to get a parabola on its side that looks like that. Okay, so the pink parabola is the inverse function of the blue parabola. And let's see, is the pink parabola a function? No, it's not, right? Because if I do the vertical line test, I cross it at two different places given a certain value of x, right? So this is interesting. I have a blue function, which when I take the inverse is not a function. Okay, so some functions don't have an inverse function. All right?